In this video, I'll review perspective, and there are certainly things here that you don't know. It's in my book, Ellen's Guide to Perspective, where the Kindle is only $5 on Amazon. I want to quickly review the main characteristics of 1-point, 2-point, and 3-point perspective. So in 1-point perspective, this structure has true horizontal and vertical lines. In 2-point perspective, which is more common, we have vertical lines but no horizontal lines. And why I say it's more common is because it shows a corner. And think of all the different corners we could see, like one over here and one over here. There are infinite number of 2-point perspective views, but only one orientation for a 1-point perspective view. So the 2-point perspective, this angle has to be more than 90 degrees, and this angle up here can be anything. And as it gets taller, it gets more and more angular. And that's a mistake I used to make as a beginner, not realizing how far angled down these converging lines were. But look how big and clumsy this tower seems on top of this building. Look what happens when we go into 3-point perspective. Now the tower seems thin and tall and far away and light. And we don't see any true horizontal or vertical lines. And the only restriction is that this angle has to be less than 90 degrees. How would you draw a box on an incline? Well, the easy way is to draw an eye level that slants with the incline, so it's parallel to the incline, and then just draw a 2-point perspective box. Now, the other question is whether if you want a third vanishing point, would you go down perpendicular to this eye level as you normally would in 3-point perspective, or would you use a vanishing point vertically below to emphasize gravity? This is an example of 3-point perspective, and we have 2 vanishing points on eye level and a third one up here. And this angle always has to be less than 90 degrees, but as you can see, it almost is 90 degrees. And that places the center of vision very high in the picture, as if the viewer is looking almost vertically up. And we get this center of vision by drawing lines from each vanishing point perpendicular to the other side. And when we do that 3 times, the lines meet at the center of vision. How would you draw this? Well, you need to set up a grid for the part that we see and then mark off important parts of the form. Then draw the same grid below, and with vertical lines find each point below that correspond to the points above. And then you connect the points, especially the parts that we don't see, and then you can get the form. How would you draw this pattern in 1-point perspective? Well, the easy part is to find where these vertical lines hit this measuring line, and then have each one of those lines converge toward the center of vision. The problem is, how do you find these horizontal lines? And what you can do is you can find the traces for this part of the pattern and put it on the x-axis over here, and then have each one of these points converge toward a vanishing point on the other side of the center of vision. And where it crosses this line going to the center of vision will mark these various horizontal lines. What do you think is wrong with this picture? Well, let's start here and see if this area was drawn correctly. And if you look over here, you can see that the diagonals go to a vanishing point up here on eye level. So this area was drawn correctly. This area looks like it slants upward, and that's because if we go over here, we can see that the vanishing point is above eye level, and that's why this looks like it tilts upward. Now this area doesn't look right at all, and that's because these diagonals don't converge at all. What do you think is wrong with this mushroom, and where is eye level? The problem is that these lines shouldn't meet at the corners like this, but rather they should go to the perspective center of the stem, this elliptical stem. If we draw a line through that perspective center to the edges of the ellipse, we will find the tangent points, and the trapezoid containing this ellipse must pass through those tangent points. If we follow these sides of the trapezoid to where they converge, we will find eye level. How should the elliptical wheels on this tricycle tilt? Well, the minor axis always has to line up with the axis of the cylinder, so the major axis is going to be perpendicular to it. Here too, the minor axis lines up with the pedals, so the major axis has to tilt in this direction. How would you put ellipses on the sides of this box? Well, this ellipse, its minor axis goes to the right vanishing point along with this line, and this minor axis on the right goes to the left vanishing point along with this line. This example is drawn correctly because we see this minor axis goes with this, and this minor axis travels in the same direction as this, and the one on top has a vertical minor axis. But when it comes to actually drawing images on the cube, you want the lines here to follow the lines of that particular plane. So, for example, this green line here follows this one. Besides my book on perspective, I also have a book called Color, Light, and Shading. I have a book on casting shadows and the art instruction course, which goes over the basic elements of art. They're all in Amazon.